In this lesson, we're going to look at an example problem where you have to add up three vectors that are in 2 dimensions. And the key to adding any or solving any of these vector addition problems is drawing a really good picture so you have your components clearly labeled so that you can keep track of everything that's going on. So the problem that we're going to look at is, let's say an airplane starts at some position and flies due east 620 kilometers. And then from there, they stop, have a layover, and then they got to fly to another airport that's 45 degrees south of east. Okay, so east is still this way. 45 degrees south of east is this way, right? So I'm going to dash in this line. That's our east line. This is 45 degrees. That's what it means when I say 45 degrees south of east. And they're going to go that far for 440 kilometers. And then finally, they're going to go 55 degrees south of west for 550 kilometers. Now, west is the opposite direction, right? So if I'm going to go 55 degrees south of west, that's something like this. So this angle right here, 55 degrees, or 53. Let's go with 53 degrees. Okay. Now, I have angles measured from 2 different references. I have it measured from east, or positive x, and I have it measured from west, or negative x, and I'm measuring counterclockwise here and clockwise here. So we're just going to rely on our picture to come up with the signs of these things. And if you want to put them in quadrants, you can, and then your calculator will give you signs, but it's easier really just to use your picture. So I have these vectors drawn, and let's say that they fly 550 kilometers here. I have these pictures drawn tail to tip so that I can actually get my resultant vector and I can sketch it in, right? So start to end is our resultant vector. This is our actual displacement, and that's what I want to find. That's the resultant vector. So we're adding these 3 vectors to come up with their displacement. And I'm going to do that by using vector addition, and that means I want, if this is vector 1, vector 2, vector 3, I want the displacement in x, or so vector 1x plus vector 2x plus vector 3x. And I'm going to do that again in y. So vector 2y plus, or vector 1y, sorry, plus vector 2y plus vector 3y. Those are my 3 component vectors for each one of my actual vectors. So let's get v1x. v1x is equal to 620 times the cosine of 0. And it's 0 because I'm measuring from east. So v1x equals 620 cosine 0. The cosine of 0 is 1. And so this is just 620 kilometers. We don't really have to do the math when we know that the angle is 0, right? It's all in the x direction. But as long as we're doing this problem, let's do this problem. So v1y equals 620 times the sine of 0. Okay, y sine, well, it would be the y component, but the sine of 0 is 0, so this is 0 kilometers. Okay, not shocking at all. v2x. Okay, so this one we're going to pay a little bit more attention to. There is a 45 degree angle here, so v2 has a magnitude of 440, and in the x direction that would be, okay, so this is the adjacent side to this 45. So I'm going to draw in this component. Here it is. Okay, the hypotenuse is 440, this is my 90 degree angle, this is v2x. And so it's adjacent to that 45 degree angle, so I'm going to say cosine 45. And when I do this math, cosine 45 is a square root of 2 over 2, and I get 311 kilometers. Okay. Similarly, v2y is over here, but be careful with this. This component is negative, and that's because this 45 degrees is actually negative 45 degrees. We're in the 4th quadrant here. And so you can put that in at the end. You can say that, okay, we're going to use negative 440. You can say we're going to use negative 45 degrees, but one way or another, I'm going to need this 440 sine negative 45 is going to equal negative 311 kilometers. It's really easy to remember that if you have a good picture that shows it. If you just put 440 sine 45 in your calculator, it's going to give you the positive 311 kilometers. So make sure you are paying attention to direction and your picture is good for that. Now, I should draw in my components here. This is v3x and this is v3y. We set these up to be at right angles to each other, right? And so again, V3x is going to equal 550, the hypotenuse of that triangle, times the cosine, because we're going for the adjacent side, of 53 degrees. But that 53 degrees is actually plus 180, right? We're in the third quadrant down here, and cosine's negative. So I'm going to use negative 550 cosine 53. And when I do that, I get negative 331 kilometers. Again, if you just type in 550 cosine 53, your calculator is going to put that in the first quadrant, and you're going to get a positive 331 when you should get a negative 331 based off your picture. And then V3y is equal to 550, but again, that's a negative 550 because it's going in the negative y direction there. So negative 550 sine 53, and that's equal to negative 439 kilometers. Okay? So now I have my x components and I have my y components, and so I can just straight up add all these together, but I add them with sign, right? So 620 plus 311 minus 331, that just gets me a resultant in x equal to 600 kilometers. Okay? Now let's go to our picture and see if that makes sense. They went in a positive x direction, 600 kilometers. Well, here's my resultant vector, and if I draw in its components, it's got this component in the y direction, which is negative, so our y is going down, but it's got this component in the x direction, and it is to the right, which is positive in my picture. So that does make sense that I have a positive x component for my resultant vector. Now in my y direction, I have 0, minus 311, minus 439. And so 1 and 9 is 10, 3 and 1 is 4, 5, and 7. Negative 750 kilometers. And again, that negative 750 makes sense because down here I do have a negative resultant vector. So my resultant in y is equal to that negative 750. Now, if I actually want just the resultant vector, I can go ahead and say, okay, well, r is equal to the square root of 600 squared plus 750 squared. Now you'll notice I didn't include the negative, but when I square a negative it's positive anyway, so it doesn't really matter. So r equals 960 kilometers, but that's just a magnitude. That tells me the length of this hypotenuse. And remember, a vector should have both magnitude and direction. And now we have a decision to make. We have to report our direction somehow. It doesn't really matter what you pick, but I have my picture here and I've got my components drawn here and here. This is south, right? And so I'm going to go ahead and find this angle right here. And to do that, I'm going to use the arctangent function, right? Now remember, tangent of theta is equal to the opposite side, and opposite of this I have x over the adjacent side, and adjacent to this I have y. Right? So now what I'm going to have is that the tangent of theta is equal to x, 600, divided by y, 750. Now that tells me that theta is actually equal to arctangent 600 over 750, right? Because if I apply arctangent to both sides, the arctangent of tangent is theta, and the arctangent of 600 divided by 750, so theta is equal to 39 degrees. Now how should I actually report my final answer? I'm going to say 960 kilometers at 31 degrees. Now I measured that, and that's east of south. Now you could have also picked this other angle here, and so this would have been 59 degrees, right, because these two are complementary. Or you could have picked this angle right here, 59 degrees, and then you'd have to report this in a different way. So this is 59 degrees south of east instead of 31 degrees east of south, but that's an equivalent direction.